Okay, so we're looking at number 23. This is a great question for which this approach really saves some time. They tell you that the same signal, I should always go from the end first. Let's go from this last sentence. The distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna? Okay, so distance is R. Right? So there's R. So what are we going to do? Well, let's make 16 times. The distance is 16 times bigger. Okay, well, let's pick some easy numbers. It sounds like nothing else changes other than the distance. The signal, the same signal, the signal is I, signal doesn't change, and certainly P is the power, which doesn't change. Okay, so give myself a little space here. Let's do this. Let's make the power cancel out with this 4 pi. So intensity is what we're trying to deal with. Intensity, we're wondering about the distance, and they're asking us about the intensity. Okay, folks, number 23. This is a great question for this approach, this picking numbers approach. The question asks, the distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna? Well, if we're interested in distance, that's the R value. And so we know we're going to solve for like R's, various R's. Like what the heck is going on with these R's? Okay, for the same signal emitted from the radio antenna, intensity is 16 times greater. So intensity is changing. Let's make intensity in the first case 16. So intensity for A is 16 times the intensity for B. Let's make this just 16, and let's make the intensity for B equal to 1. Right, so that A is 16 times greater. Okay, well, what does that equal to? The power over 4 pi squared. 4 pi I R squared. Sorry. Make P any number you want. In this case, I'm going to make it 4 pi. That makes my math really easy. 4 pi over 4 pi R squared. Now these cancel, and what I get for this value, just moving this over so I have a little bit more space here. What I get for this value then is I sub A, or the intensity, which is 16, equals 1 over R squared. So now I can solve for R squared. You know, you could multiply both sides by R squared. This would get you 16 R squared equals 1. R squared equals 1/16. Take the square root. R, this is for A, R sub A is, the square root of that is 1/4. Do the same thing for B. Now for B, we know this equals 1. The power didn't change. The power, which I picked myself, is 4 pi. 4 pi R squared is in the bottom still. The 4 pi's cancel. We get I sub B equals 1, that equals 1, which equals 1 over R squared. So then, of course, R squared equals 1. You could cross multiply. R squared equals 1. Square root of that would mean R sub B equals 1. So we're comparing these two values. And in this case, then, the distance is 1/4, right? So by picking values there, we made our lives really a lot easier. I'm going to bring this up just in case you can see it very well down there. So what I did was I took, just to be clear, we had this equation I equals P over 4 pi R squared. What I did is I said I'm looking for R. I can make P whatever I want. That made these things cancel. And I just had intensity equals 1 over R squared. I made the intensity 16 and 1 because that was the easiest values I could think of for making something 16 times bigger than another something, right? So that gave me the math that you saw unfold over there, right? So hopefully that's helpful. That's just a great example. Now, it's worth talking about why this is the case. At the end of the day, the reason that the intensity changes by 16 times and the distance only changes by 4 times is because R is squared. So this distance, R, here I'll clear the board, has a huge effect. We have P over 4 pi. I'm going to write R times R. So if this gets 16 times bigger, then each of these r's, look, first of all, they're in the denominator. So as r gets bigger, intensity is going to get smaller. Right? And that makes sense. As you walk further away from a radio tower, the signal will get weaker and weaker and weaker. Okay, so when r gets 4 times bigger, 4 times 4 is 16, we're now dividing by 16, which means I get 16 times weaker. Conversely, if r got 4 times smaller, 4 times 4 is 16, we got 16 times more power in this signal. Understanding that concept is great. Being able to work through it without the concept is what's probably more important for the SAT. So hopefully that's helpful.